Hello.
Bonjour tout le monde.
Dzień dobry.
Hallo.
Le théâtre est un des outils les plus importants pour partager des expériences et pour construire une entente entre les cultures. En plus, les artistes théâtrales et leur public, qui parlent plusieurs langues, sont mieux reliés que jamais.
Wij zijn Improbatics, een collectief van theatrale improvisatoren en onderzoekers in mens-computer-interactie. Wij willen graag met je praten over onze show, Rosetta Code. Rosetta Code voorziet improvisatietheaterartiesten van op kunstmatige intelligentie gebaseerde technologie om een show uit te voeren die in veel verschillende talen begrijpelijk zijn.
We combine speech recognition, improv chatbots, and language translation tools to enable improvisers to communicate with each other while being understood or comically misunderstood by multilingual audiences.
In deze presentatie gaan we dieper in op de technologie achter Rosetta Stone, met details over de spraakherkenning, de automatische vertaling, de tekstgeneratie en de tekst naar spraaksystemen.
Bonjour, nous décrivons ensuite la structure de scène qui présentent le système dans des performances multilingues. Nous avons un spectacle en 9 langues.
Dostarczamy oceniających informacji i recenzji od wykonawców, widzów i krytyków. Na podstawie tej opinii wyciągamy analogie między surrealizmem, absurdem i wielojęzyczną improwisacją ze sztuczną inteligencją. Nous vous montrerons comment Rosetta Code, la pierre de Rosette, établit une nouvelle forme d'impro fondée sur la langue et l'absurde. Nos spectacles sont éphémères et les improvisateurs s'expriment en des langues différentes tout en respectant la diversité linguistique de leur audience.
But first things first, what is improv anyway?
Improv is theater without a script. It's made up on the spot. Improv is theater that is created and performed at the same time.
Yes, and?
The art of improvisation is derived from the connections between the performers and between the performers and the audience. Improv embraces the audience to create collaboratively together. Improv serves as a microcosm of cultural communication. It is the theater of the people. Given that improv is based on the connection between the audience and the performers, watching improv in a foreign language severely limits the link between improvisers and the audience. This contrasts with scripted theater. Sophocles, Sartre, Shakespeare continue to be translated into many different languages, reinterpreted and enjoyed by audiences around the world. Improv has not had such an opportunity, and performance groups are bound to remain local or switch to English as a lingua franca when performing internationally. Without translation, improvisation misses out on important voices due to language limitations. So, how can we enable improvisers from different cultures to improvise together in their own language? How can audiences understand performers using different languages? How might we grow our cultural communication and empathy while only being able to speak one language? Rosetta Code answers these questions and gives theatrical improv a suite of software, scenes, and show structures from which to advance and expand. Our starting point is artificial intelligence-based improvisation, where a robot and/or an AI is used on the stage as an improv stage partner. In our case, the robot relies on a generative language model to produce lines or actions in response to context, and can in itself be seen as a computationally creative system. To respond meaningfully to human improvisers, the AI improv system works by using a statistical language model to generate sentences in continuation of some context. We currently rely on the GPT-2 neural network transformer architecture trained on a large corpus of web pages, which we fine-tuned on the open subtitles corpus of film subtitles. Note that the language model chatbot, which predicts what sentence comes next, acts like a sort of translation from one language into that same language but one sentence later. The AI improv chatbot controlling a human performer can be seen as a difficult but funny and absurdist stage partner. A variation of that AI improv format, Improbotics, designed in 2016, consists in letting human actors enunciate the lines. The chatbot effectively whispers lines into the ears of human improvisers who are only allowed to repeat exactly those lines, but are otherwise free to express themselves with a full vocabulary of physicality and emotions. We have adopted this configuration for the Rosetta Code show, with lines either generated by an AI chatbot or by translation from one language to another. The technical setup used in this project consists of several elements that can be seen as independent building blocks, each corresponding to a piece of equipment or to an application programming interface. We rely on speech recognition, such as the Google Speech-to-Text API running in the browser, and on handheld dynamic microphones with an on-off button to filter out noise and voices of other improvisers. We also use an instantaneous translation system, for instance the Google Translate API, to project subtitles on the back of the stage to let the audience follow the conversation using instantaneous translation. On this picture, you can see the top part displaying the choice of a language used for speech recognition and the latest recognized sentence, here in French. The bottom part shows the target language for machine translation, here Polish, as well as the last few translation results. The buttons and input box on the top enable to override speech recognition and activate or deactivate text-to-speech. We rely on standard text-to-speech synthesis APIs and are happy with slightly robotic sounding voices. Improvisers rely on in-ear headphones to follow the audio translation while still being able to converse with the other improvisers and move on the stage. Our setup relies on FM radio transmitters that can broadcast to multiple FM radio receivers worn by several improvisers. Games. There are several improv games that can be played by multilingual improvisers using our simple setup. Translation-free games that do not require a translation service, translation-based games, and vocalization-based games. Translation-free games build upon the gibberish improv format, in which one or more of the performers speak in a non-existing language. In our case, that language exists. Absurdist playwrights, such as Samuel Beckett or Eugène Ionescu, saw language as being purely aesthetic and devoid of significance. The theatre of the absurd shows the world as an incomprehensible place. In our case, each performer is allowed to express themselves by formulating real language. The first game is Stranger in a Strange Land. A stranger does not understand the language of the others, and the others do not understand the language of a stranger either. This game can be played when several minority language performers improvise, for instance in Dutch, with a majority language performer and for a majority language audience, for instance English speaking. This reverses the usual majority-minority status relationships faced by minority language speakers. The second game is Languages of Love. Two performers are on a blind date but clearly speak a different language. This is a setup that invites the performers to seek equal status. Tower of Babel. Every performer speaks a different, unique minority language and does not understand the language of the others. These games were all designed to investigate how meaning and understanding can emerge without words and force the performers to explore alternative means of communication via body language, signaling, and bold assumptions. Most importantly, they provide opportunity for comedic confusion. We have then devised new games that rely on speech recognition, live translation, and a combination of earpieces for performers and subtitles for the audience. The first one is Lost in Translation, a translation-based equivalent of Strangers in a Strange Land. A minority language improviser speaks in their own language, with live translation projected on subtitles that the audience can read. The remaining majority improvisers cannot. They are at a disadvantage and need to make educated guesses about what's going on. In the second game, foreign film, every performer speaks the same minority language, and the majority language audience sees the subtitled translation of the scene, thus being able to connect with the story told by the minority language players. Finally, we introduce the most technically ambitious game, Babblefish. It combines all those ideas. Improvisers perform in different languages and understand each other via live translation sent to their headphones, while the audience watches multilingual translation subtitles. Everyone can understand everyone else, but with time delays, speech recognition errors, and machine translation errors. Finally, and rather than focusing on multilingual understanding, we go back to the linguistic experiments that were dear to the surrealists and that were done purely on the sound of words. We adapted two existing translation-based games inspired by Raymond Queneau's Pour les Anglais, a seemingly gibberish text that makes sense in French when read aloud by an English speaker. The simplest game is the telephone game. Performers are aligned and one whispers to their partner on the right a phrase in a foreign language, here in Swedish, which is then repeated to the following performer until the last utterance is voiced into automated speech recognition and translation to show how information is lost. The second game is Diplomat, trying to repeat a speech in a language that one does not speak. Simple. In all these language-based games, the varying ratios of information asymmetry between the performers and between performers and audience, and all the misunderstandings create multiple opportunities for comedy. In our paper, we also detail how we can use speech recognition, machine translation, and text-to-speech in a feedback loop to achieve automated translation to meaninglessness. Check it out. So, using the technology and interface I just described, along with the various games we have reused or devised, we came up with the following script for a language technology-enabled, scene-based, improvised comedy show. We aimed at building the show along a narrative arc with a stunning revelation where the AI tools, which we use for speech recognition, machine translation, text-to-speech, end up getting a life of their own and taking over the show. This way, we remind the audience that today's multilingual communication is enabled by machines with their own limitations and sources of errors. By delegating language generation in improvised scenes to a machine, we force the performers to find and create meaning outside of the realms of verbal communication. We also combine the idea of multilingual improv with real-time translation, as we do in Rosetta Code, to implement a non-English version of AI improv comedy, such as Improbotics, and to enable an existing AI improv chatbot to work in multiple languages. Specifically, we made two multilingual versions of AI improv shows, of Improbotics AI improv shows, one performed in Sweden, in Swedish and English, and one in Belgium, in Flemish and English. Using an English chatbot, for instance built on GPT-2, and a good quality translation service from and into Dutch or Swedish allowed us to avoid fine-tuning or retraining from scratch Dutch or Swedish language models and having to deal with non-English tokenization and very costly learning. This approach has been successfully deployed in several shows in Flanders and in Sweden shortly before the lockdown. And now onto the show. Rosetta Code was designed in 2018 and performed as a full show twice in November 2019 at the Voilà Europe Theatre Festival, a multilingual festival often programming performances that use 2 free languages in the same show, at the Rich Mix Theatre in London. The framing of a show was detailed in the show's description in the festival program and on stage, making clear to the audience that the computer assists the creativity of the improvisers using automatic translation in 9 languages: Arabic, Dutch, English, French, German, Italian, Polish, Spanish, and Swedish. It was presented as a multilingual Turing test, where the challenge for the audience was to decipher who is human and who is the robot. The show received positive response from performers, audience members, and critics. For instance, one quote from a performing musician reinforces the novelty and innovation of the show. The festival organizers observed the comedic potential of the translation and miscommunication, which was nice. The show was also previewed and reviewed by multiple theatre critics and experts in innovative technical improvisation. Selected quotes from reviews of the show include references about how the technology initially seemed intimidating, but ultimately augmented the humans. They also acknowledged that the system is not perfect, but rather that there is beauty in the mistakes that are made. Observers also noted that the AI tools that underlie the show are built iteratively over the course of the performance. You can watch an edited video of a 1-hour performance of Rosetta Code on YouTube at this link. So, why did we choose the name Rosetta Code for our show? The Rosetta Stone, after which Rosetta Code is named, is a historical artifact discovered in 1799. It is inscribed with 3 versions of the same decree issued in Egypt in 196 BC. The texts are in Ancient Egyptian, Hieroglyphic and Demotic, and Ancient Greek. Our ambition with Rosetta Code was to provide a platform that can help us explore the power of translation and making meaning between collaborating humans. We acknowledge that there is a lot to be understood about others through interactions that are not based on language. Dialogue between individuals can happen through many means, including, but not limited to, vocalized language. In our shows, we leave that part to the human performers. One could ask, why are we interested in linking AI, language models, and theatre? Modern speech recognition, machine translation, and dialogue systems share the same underlying mechanism: statistical language models that are trained on large corpora of text and that estimate the likelihood of a next word or character token given some context about previous tokens. These models cannot ground language understanding in the human sense. They rely on large amounts of training data and a well-defined training objective. These limitations can be linked to classic theatre theory and actor training. The seminal Russian theatre director and theorist, Stanislavski, explained that the mistake most actors make is that they think about the result instead of the action that must prepare it. That is, most actors in the late 19th century Russia understood what to say next, but not why they might say such a thing, or how it might be organized in a deliberate and impactful way. This mirrors the capacity of the computational language models, which know the likelihood of what might come next, but not why or how it should follow. Of course, actor training, as championed by Stanislavski and his followers, has drastically changed, and today's actors and performers build on deep intellectual and emotional understanding of the script. The language models that we have been using in our shows serve as building blocks for augmentative theatre technology, allowing performers to bring AI on the stage. Unfortunately, many of those models, in particular dialogue systems, are trained on large data sets of strictly English text, which limits the applicability of such technology for non-English improv. In our work, we demonstrated several ways of overcoming these obstacles by combining chatbots with translation for multilingual AI improv shows. Each presentation and paper normally finishes with a section about future work. But between the submission of this paper and its presentation, a once-in-a-lifetime plague has ravaged livelihoods and upended theatre, improv, and all kinds of live performance. I am optimistic and I know that there will be future work, not only online but also on the stage. We shall tread the boards one more. So, future work will involve systematic quantitative evaluation enabled by online performances on the stage, and by sharing the tools with more improv troupes. Our framework allows for performers and audiences from around the world to enjoy improvised theatre in any language, and we hope that these tools and techniques will empower and augment the art form. We will also explore incorporating language technologies with computationally creative systems for video and music generation. Thank you.